Ages. What is age? Huh? Softness of, because that is also important. As I mentioned to you in one of the class, when depending on this person is using on the image, right? Especially the boundary of the two class, that is always confused. Correct? Because one pixel will have just one digital number, right? So, but then if the pixel is falling along the border of a boundary of two different classes, it is very, very confusing. So therefore, exactly determining actually the age is also very challenging. Okay? So you will have some error and so on. Okay, so today we will be looking at that. I have two lectures actually to finish. The second part is more interesting. Actually, it's on water quality mapping and monitoring. Okay? All right. So let's look at the methodology. Let's derive actually. You see, all my lectures are like this. We'll have objective, we'll have the methodology, but then we can do some discussions, how we can probably think about establishing a methodology, what are the data that we can use, and so on. All right? So let's say the basic procedures normally that we use in this kind of study is that in the data fusion studies, data fusion can be done, as I mentioned, in the same sensor, at the same satellite, but different sensor, or it can come in from the two different satellites. Okay, so you have the fuse data, correct? Most of the commercial image processing softwares, they have all kind of these tools. Straight away, actually, you can employ them and you can actually apply them. Okay, all right, but the next stage actually, in order for us to determine a feature, we can also look at actually the digital number of the pixels, right? Because each and every type of features, they have a significant value, the reflectance value, when they interact with the electromagnetic spectrum, right? A grass, a different type of grass, different type of trees, plants, housing, depending on the roof materials of the house as well, roof materials. Yeah? You have zinc, probably you have copper. If you go to European countries, like some of the buildings also they have the copper, right? Especially the churches and so on, right? So depending on the type of materials, the interaction with the electromagnetic spectrum, right? So you can be able to view through the reflectance of these pixels, correct? So if we can do, or if we can actually gauge and know that what would be actually the range of this reflectance value, probably we can come up with a threshold, correct? Right. Let's say we know that, well, a 3 months paddy doesn't work for 3 months. Okay, well, 1 month, okay, 1 month paddy, correct? Depending on the land, okay, and so on, the amount of water that will be there during that 1 month time, because still actually you are doing the farming stage. So that will have a distinctive reflectance on your image, correct? So if you can actually determine that values, the range, we can come up with a threshold value. In previous class, I have given actually example of the water bottle, like the flooded water bottles, to differentiate between the normal water body and the flooded water body, and so on. So well, what we did basically, we did a simple minus. First, we come up with the normal water body conditions. Then we map all the water bodies, then we minus. Correct? Obviously, then you will find actually the flooded water bodies. Right? So thresholding is a very common technique that is being used. But then you still have some uncertainty in certain number of pixels, not knowing the fact that whether they are exactly belong to this particular type of class. Correct? Depending again the type of sensor you are using, the spatial resolution, spectral resolution, and so on. If we go to the little bit higher level, we can also use different kinds of filtering techniques. This is what you call the post-image processing. We have the pre-image processing and the post-image processing, right? So filtering there are different types of filters that we have. Correct? We have low pass filter, we have high pass filter, depending on the objective. Which content of the information of the image that you would like to suppress, or which content that you would like to highlight. That is depending on the type of filter that you're going to use. So it all works in the frequency domain. Right? So there are so many types of filters. You have Gaussian filter, you have gradient filter, you have mode filter, and so on. Basically, what are they? What they do?
Enhancement.
Huh?
On the processing software.
Yeah, this is an enhancement, right? But once you apply a filtering technique, basically you are altering also the values of the pixel. Correct? The DN values. So it's an irreversible phenomenon that you are going to apply. Correct? So this is also one option that you have. Once, why? Because you want to actually make your image more sharper. Like how you are playing around actually with your photo. Correct? To make yourself beautiful, the eyebrows to be very clearly visible, and so on. So you see, you play around with the contrast, right? Brightness, and so on. So in this case, since you have actually many bands to play around with, because your photo is just actually mono, isn't it? But here you have many bands to play around with. 7 band, 8 band, in hyperspectral you have hundreds of bands, right? So you can be able to apply this. Alright. Once you have made your image now, after filtering, to make it more better quality, sharpen, and so on, you can apply some classification techniques. Okay? Well, you can also ask, I may apply the classification technique here as well. Why not? Yes, you can. But then your pixels actually, they are not distinctively separated. Correct? Yes? Yes means yes.
Yes.
Yes. Good. All right. So once we go to this stage, this is a very general steps that I am telling you. Once you go to this step, you have different options. Again, if you are lazy, okay. If you are lazy, you don't have time, and you don't mind whatever results you get, it is okay. Then you just ask the computer to do the job. Correct? Yeah? So in that case, you engaged what you call unsupervised classification. Correct? Unsupervised means basically you are asking the computer, since you already have made or sharpened the image to a certain extent, now you are asking the computer, find out the clustering pattern that you can identify in my image based on those DN values, pixel number values. Okay? So the computer will look through, run through your image, then you will find actually the cluster. Then you will identify the number of classes that you like. It's also you can do that. I mean, you can, there's a 5 class, 3 class, 6 classes, depends. Right? So that you can do that. So ISO data actually is one of the very popular unsupervised type of classification. Are you understanding what is unsupervised classification or not? Yeah, good. Then the next level, but not necessarily as I mentioned, that you are going to get actually very good result. Correct? Because it's basically you are not supervising. You are not sure about it. You are asking your computer to do it. Otherwise, you can also go for supervised classifications. It's a little bit tedious, but at least you control your result. How? How is it being done? The process starts with
Sampling.
huh?
Sampling.
Sampling. Sampling like I'm asking very simple question.
It's easy by field work using GPS or by Google Map.
Okay, right?
The restrictions is already known by the
Yes.
user.
So basically what you do, you look at the image, then you identify some of the features which you are 100% sure that this belongs to this particular type of class. Let's say you have 6 types of land cover on your image, correct? You have paddies, you have primary forests, you have some built-up areas, you have road networks, then you have some water bodies, and maybe you have some all park areas, correct? So then you know that because you are looking around the image, then you play around with the bands and so on, look at the vegetation difference and so on. Then with surety, you identify some of the pixels. Those are called training pixels, right? So the distributions of those pixels has to be homogeneous. Homogeneous in the sense, it has to be well distributed over the image, not like only one side. Unless it's one side, you are having one type of class. Okay, number 1. Number 2, you are 100% sure that these are the classes that, okay. Now, you store in the computer and you tell the computer that this is the value of the digital number values or pixel number values for these are the classes that I have identified. Okay, alright, and you know that. So based on your assigned value, then the computer will look around for the entire image again by applying some techniques, algorithms. Correct? There are many types of algorithms also available for supervised classification. Alright? So the most important process actually is identifying those training samples. Okay? That also has to be confirmed by going to the field, as you mentioned, because you want to ensure that this is what actually it is. Alright? And then, but how to confirm, let's say you are looking at 20 years old image. Let's say you are looking at a 20 years old image, you are doing some change detection, then how to confirm? Also, you may need actually some ancillary data as well. Okay, some supporting data as well. Because you see, it's all about, otherwise, as you know in this process, you just run the machine also, it will do for yourself and for you. Correct? You will get some result, no matter what. Correct? So, in order for you to obtain high accurate result, you have to ensure that these processes are verified and you are sure about it. Okay? Now, once you do that, again, unsupervised or supervised, or nowadays we are using the OBI, object-based analysis, image analysis. Okay? Correct? So there actually we are using different properties of the image to classify it, like shape, the spectral information, spatial information, and so on. Okay? So now, having classified the image, you can be able to extract the features. The same also goes for once you extract the features, it's also possible to extract the edges as well. Okay? But now, there are different types of features that you have. You have linear features, you have non-linear features, so on. Correct? So depending on the type of algorithm that you are using, also is going to tell you whether actually how successful you are going to in terms of identifying those features or not. Everybody understand this or not? Okay? This is the general procedure, you know. So no matter what, this actually remains. Okay? Now let's look at one particular type of transformation here. That is called IHS transformation. Intensity, hue, and saturation transformation. What it does basically, if you look at this particular flow that I have put here, you have, let's say, spot image. You have panchromatic as a mentioned, and also you have panchromatic, and also you have the multispectral. Correct? So there are actually many types of algorithms that you can use. Some of them, anybody can tell another algorithm that you can use. For another one. Many, there are many algorithms. Okay? So it's sometimes actually worth looking at which type of algorithm actually provides you the better result. But then, always the literature is there for you to refer. Because people have done already a lot of work. Instead of doing again 10 or 12 types of algorithm and you try to claim that, okay, this is going to be my result and I can try to publish. No. Because it's a general process, you know. So the literature is going to tell you basically which or what objective is going to be more useful. Yeah? So let's say you have multispectral, here you have panchromatic here. So then they apply the intensity, hue and saturation transformation. You see here, for example, they basically do the color transformation. Okay? Both color transformation and also inverted color transformation will be applied here in this case, which basically brings in the spatial resolution of the panchromatic band and brings in actually the spectral content of the multispectral band. Okay? I'll show you how it looks. Look, the first one is the spot panchromatic 10 meter. Okay, this is just actually after doing the geometric correction. Geometric correction is a standard, isn't it? Any image that you obtain, first thing first is you like to put them in the right coordinate. So that to ensure that where you are, the location, yeah? The second one, you look at it, Landsat TM 30 meter after geometry register with spot panchromatic. So when you do the geometry correction, also you have different options as well. You will be running in image processing. You can do simple using the GCPs, which is collected from the field, or you can also collect the GCPs from ancillary data, such as a map or any other relevant data that is useful for you to identify those GCPs. Number one, that's the traditional way. Number two, if you have many images to look at it, you can do also image to image geometric registration, right? So that means you select in both the images which you think that these are the same features, same locations, then you try to transform. That means one is already geometrically corrected, another one is not. Then you force this one to follow this. Okay, image. Yeah. So this is done basically. Landsat TM was done based on the spot 5 panchromatic image. Yeah. This one fuse image, merging spot panchromatic with Landsat. So 10 meter, you have more spatial, then you have more spectral content coming from the Landsat, and you can see the difference between them. Yes, this is the individual, huh? This is just actually the Landsat image, correct? The same area, this is actually the spot panchromatic, correct? But there is no spectral information here. So once you merge them, you can see that it has enhanced. Okay?
The time to publish.
Very important.
Very important.
Very important. Because the time, why the time is very important? Can I, let's say, I had
Season.
yes, seasonal variation also plays a role actually in terms of the spectral interference of the features. Correct? Also what time the image has been captured, that also. But anyway, I presume that all these factors has to be constant, has to be eliminated. You must do your atmospheric correction in order actually to eliminate this what time of the day you are taking the picture. Right? Because you have the sun glaring effect, you see. Because an image, if you are capturing at the mid of the day, it will be different spectral reflectance than taking maybe in the early morning or actually in the afternoon. Correct? So all these things need to be calibrated and need to be corrected before you go into this kind of process. Yeah? So now to see actually the difference, this is the original Landsat TM image, and you can see after you do the data fusion, of course you have enhanced. Okay? So I'm still showing actually some of the data which is free. I can also show the data actually, some beautiful iconos and so on. But then it's very expensive. You know, iconos is, they sell actually per square kilometer. about 35 or 50 US dollars, something like that. Yeah, one SIM minimum will cost you around 2,000 ringgit. Minimum, small SIM. Okay. So, see the band that I put here. That's also very important. As I keep on saying, the way actually you select your band, you assign those bands into different your RGB. That also is going to tell you a lot of information about the features. Okay? So do not actually always overlook at the visual inspection part. Right? Because we know actually, because the human being knows much better than actually the computer, isn't it? Because we ask the computer to do what we want the computer to do. Alright. So now continuing with the story. Thresholding, as I mentioned to you, thresholding basically is identifying the gray level values. Now I can say gray level values, right? Or the distant number values that separates between two different type of classes. Yeah, that is what we call threshold. Correct? Maybe a water body and a non-water body. Right? So that is what we call the thresholding for the water body. Correct? So, for example, in this case, certain thresholding values have been applied in order to identify different types of features. They are not the same type of features, isn't it? No. So finally it has been merged then. Correct? So let's look at the process. As I mentioned in the second slide, there are different kinds of filtering that we can apply. Correct? To identify those features. So in this case we use the low pass filter. There are many types, of course, mean, median, and so on. Yeah? So first actually you use the filter basically to smoothen out the image. But you don't smooth out so much so that actually you will have a blurry effect. Right? You like actually still you would like to optimize the image in terms of its contrast, in terms of its histogram stretching. Okay? So optimization is very, very important. So because if you put too much, basically you will get the blurring effect. Yeah? Then coming back to that flow that I was mentioning you, then let's say ISO data, the unsupervised type of classification you apply. So the same image that you can see that automatically the computer will try to identify the different types of features depending on the cluster algorithms, ISO data algorithm. That computer thinks that these are the pixels. They forms to one group of pixels, one range of pixels, or this number of values. Correct? This is for this. Okay. So, but you see, but still, if you don't have time, you still say that all right, I don't mind. So then you still can come up with a pretty good land use map. Okay, I would say land cover map. A land use map is very difficult. What's the difference between land use map and cover map? We always combine that. But land cover map is pretty easy actually to derive using this kind of method. But a land use map is difficult. Correct? Because land use is one step going inside, going deeper. Correct? You would like to know how the land has been used. In a land cover map, probably you can put vegetation is enough. Right? But in a land use map, you must put paddy, or you must put actually, okay, forest areas, then you must, the vegetation can be anything, agricultural areas, horticulture areas, what type of horticulture, maybe the coconuts, oil palm, rubber, and so on and so on and so on. Right? So this kind of information is difficult actually to obtain through a very simple unsupervised type of classification. Okay? Understand?
Yes.
So you can see here it's just actually green land features. That means it's just vegetation. That's it. Then you have urban features, then you have some highways and road features and so on. Well, you see, whatever application that you do in remote sensing, it's all coming back to this. Because feature identification is the most important thing. And how many years people are working on this? More than 30 years. But still, the separation between the two different classes is still a big problem to handle. Okay? All right. Then the next step actually would be to do some accuracy assessment, because any results that you produce, it's very important also to say that what is your accuracy. 70%, 10%, and so on. Correct? So this is a very standard way of measuring the accuracy through a confusion matrix. Why it's called confusion? Basically, you put actually in a matrix table, you classify actually, you take some reference data, correct? Reference data which is not being used, correct? You pick some reference data, which you know already basically this is this type of class, this is this type of class, this type of class. Then you put them in a matrix format along with that what actually obtained from the result, right? So then you can map them in terms of what is the accuracy. Very simple mathematics they use. You can see here the different types of class, and for each type of class, what is the accuracy there? So there are two accuracies they get. One is called user accuracy, another one is called producer accuracy. But then at the end, actually, is the overall accuracy that we use. Correct? So in this case, you see some overall accuracy just let's 5 class. So this is how they come. Very standard procedure. Okay, yet still very useful. Okay, so for example, here in this case, it says about 89% of the overall accuracy that we obtain through this ISO data type of classification that we have. Right? Okay. Next, any questions you have so far? Got? All right. Next, let's move on to the next one is the age extraction. Okay. Age. As we mentioned, there also can be different boundaries between the different type of classes. Correct? How can we extract it? Any idea? Force your brain to work with it. You know the answer actually, you know. It's just forcing you with.
In this case, the higher resolution is very important. The high resolution.
No. In this case, we just replace the same kind of process, but in this case, we just replace the type of filter that we use. We just apply the previous one we used maybe low frequency or high frequency, correct? In a low frequency domain, but here in this case, we will be applying more to gradient type of filter, correct? So what happens? There are different types of edge detection type of filters like Sol filter, there are many. Okay, Sol is quite popularly used in the literature. No? So then again you come up with the thresholding value. Thresholding value you need basically to separate out with different types of classes again. Correct? It's a similar process. It's just actually the selection of the filter that you are going to use. Now, if you look at, let's say, when you use the filter, you can also have the option. What is the window size that you are going to use? Window size is the this is called kernel, right? So the kernel size basically was 3, 5, 7, and how do we know that which one is better? Is it a bigger window size is better? And what does it do? Correct? It's a big question.
Right.
What does actually, when you apply a filter, a window, right? What does it do? In a physical way of explaining, not mathematically, maybe physical.
Size of image.
Yes. Let's say, because if the concept you understand, you will never forget. You don't have to memorize anything. Let's say, okay, this is your agree on. This your image now. Not the same pixel size, but okay. Alright, so now if we apply a 3 by 3 filter, what does it do? What does it do to the image? Physical. What is it?
Change the center value for when.
Yes. Basically, depending on the type of filter that you use, that's why you have different type of filter, isn't it? You have mean. What does it mean? Not mean.
Average.
Right? Then you have median.
Media.
Then you have mode, and so on. Correct? What do they do? Basically, 3 by 3, right? So this window basically it just goes like that. Goes like this, comes back. So what it does once it goes here, so the image that it passes through, it takes actually the surrounding pixels, average out, depending on the type of filter that you're using, assigns the central pixel of the value that actually the type of filter that you're using. If you are using median filter, it will take the median value. If you are using mode filter, it will take a mode value. So basically you are altering the value of the pixel. Correct? So that is why I mentioned to you, you have both high and low. Because some low spatial information or content features that you would like to suppress in the image, right? Based on that, actually, you apply the type of filter. Okay? Now, here, you see a 3 by 3 kernel that is being used here. This is for gradient. Let's solve the type of filter, edge filter. Yeah? What it does, see here, you have the first one, huh? Look at the equations. -1, 0, 1, -2, 0, 2, -1, 0, 1. Okay? You have x, then you have y, and so on. So how does it calculate? It takes the x information from here and here. See here, if you look at actually the equations, x equal to I and -1, yes? First one, I1 plus 1, the right one, right? I3 minus 2 coming from there, then you have 2 and so on. Okay? Are you getting or not? If you take this and take this, you get this equation. Right? -1 I1, correct? Plus 1 I3, I1 I2 by 3, correct? And so on. Then you have -2 I4 plus 2 I6. Then you have -1 I7. Then you have -1 I9. You get your equation, right? You don't have to think so much. Okay? The same thing also you apply here because it's a gradient filter, correct? Why? Same thing. This one and this one you get. You get your equation. So by applying this, then the next step actually, once you have your x and y, which is calculated using this Sobel type of gradient, it calculates actually the overall Sobel gradient would be a simple mathematics, x squared plus y squared square root. Okay? So that actually the value that is going to be. Okay? Simple.
X or Y is actually
Yes, depending on actually the what type of filter that you're using. Okay? Alright? Now, once you apply that, these values for different types of features, then you see that automatically it is recognizing and identifying the features. Urban areas, these are actually the edges. Correct? Building features, this is the gradient of the process, huh? This is the feature, then you take actually from the classified, then you apply the urban gradient image, then actually you apply just the edge. Same also for building. So, road, this is very, very useful when you are some linear features that you want to map and identify, such as roads. Okay, and also some geological information, let's say the rock outcrops that you want to map, and structural information such as fault lines, lineaments, also dissolvable and other type of cases which is very, very useful. Okay, then you see here for clear line also. Clear line is the line. Okay, water bodies similarly. Once you combine all of them, you already find actually the edge detected from your image. What is the difference between binary edge and the gradient image? Just now I showed you actually the equations. There are 3 steps. This is what actually you get at the end, the final one, the 3 steps that, right? So this is what actually you get at the end. Once you apply this is the intermediate step. Okay, it's almost similar. If you look at the results, it's almost the same. It's just actually retuning or refining your edges, that's all. Nothing else. Because if you look at the equations, x squared plus y squared square root, you just get a technical gradient. Isn't it? That's all. But it's almost the same. You look at the result, it's the same. Okay? Okay, so now once we combine them, all the features in GIS, we can be able to obtain all the edge that you have detected from your image for different type of landform process. Okay? Let's apply this on a very high resolution data set. Iconos, 1 meter. Okay? First step, you classify the image. Maybe you just apply actually the ISO data, never mind. Okay? Simple, because it's not very complex area, you can see that. This is one type of, these are the buildings, this is the water body here. Then you have actually, what are the features they have? Yeah, some open space and blah blah blah. But you can see it's not very accurately mapped, not very accurately classified. Huh? You can see that because this is what is this actually? What is this? This is vegetation. Because depending on this is why I say that. What time you are looking at it? Okay, vegetation is very good. I mean, which band is very good in terms of vegetation mapping is infrared, right? So you see the reason. Okay, so then then you map. You know already. Okay, these are the different types of features and classes. Then you apply the technique I just mentioned to you. So detect the edges of the different type of feature, different classes of features. So you have for residential, then you have the industrial, then you have roads, then you have the clear land, and so on. Water bodies.
Which software?
Any software you can use. Or more or less all the softwares are the same. It depends on how you feel comfortable. Otherwise, you tell me, if you are a software vendor, would you be able to sell your product if they are not actually same with your on the your friend. Hmm? But it all depends on how user friendly that you make actually the software. That's it. Almost same. 15 years ago, or I would say 20 years ago, address margin used to be very good, number one in the US system.
Which one?
Address margin.
Okay.
Now we don't use it that much. It's a light car, isn't it? Yeah? But now you see, now it's NV has taken over. How they have taken over? This is all strategy, business strategy. They allow, they made it a bit flexible. They made it a bit like open source kind of thing. Not fully open source, a little bit open source. So the researchers also can contribute to the development of that. Let's say you have a objective, specific objective. Now you develop all your modelings and everything in MD. That's it. Is done, then you just incorporate the same thing actually in the toolbox. Finish. I hardly see actually address margin is being used. 20 years ago, it used to be number one in USPS. Now you're using FD. Correct? Same thing also Idris. Idrisi. Idrisi used to be very, very popular software because it's free. It used to be free, it used to be user friendly and so on. Compared to Arkinfo. Right?
Yes.
But right now you see, they're everywhere. Map info also used to be very, very famous once upon a time. All the government agencies actually used to use map info once upon a time. Now